morning, students. In our previous class, we saw classification and the introduction of halogens. In this part, we are going to discuss about nature of bond. We know very well all the organic compounds have covalency, and mostly when the covalent bonds are formed, carbon participate into sp3, sp2 and sp hybridization. When single bonds are formed between carbon and other element or between carbon, at that time carbon participate into sp3 hybridization. Whereas when carbon and carbon form double bond with the similar carbon atom or other element, then it participates into sp2 hybridization. Whereas when carbon form triple bond, at that time it will participate into sp hybridization. Here we are going to discuss about nature of bond of haloalkanes. When the covalency is formed, at that time bonds can be of two types. Either they are non-polar or either they are polar in nature. Normally, haloalkanes are polar in behavior. Why polarity is developed? In last classes or in 11th class, you already studied when the covalent bonds are formed, and if one element attached with the more electronegative element, at that time it will attract to the shared pair of electrons. What is electronegativity? The tendency to attract the shared pair of electrons. When the sharing is going on, when the bond is formed, after that they attract to the shared pair of electrons. A pull is created by the electronegative element. When we talk about halogen, we know very well fluorine is most electronegative element and its electronegativity is 4.0 electron volt, which is highest. After that oxygen 3.5 and after that other elements are there. It means when carbon attached with either fluorine or chlorine. After that, chlorine or fluorine, if fluorine is there, high pull can be there or attraction is there, and due to that what happens? Shared pair electron is attracted toward the more electronegative element. Means what happened? Actually sharing electron should be lie between the two covalent elements. But what happened here? This shared pair of electron is attracted toward the fluorine. It means electron pair is shifted toward the fluorine. And due to that what happened? A partial negative charge is developed, not complete. Little bit charge is developed, and this charge is developed is depend on the pull. If pull is highest, the tendency or the charge will be more. And if pull is less, then charge will develop will be less. So partial negative charge is developed, and due to the lack of density near the carbon atom, partial positive charge is developed. It means what happened? Now bond is not complete pure covalent bond. Now it is mixes and it will have ionic character on it. Ionic character इसके ऊपर क्या हो जाता है? Develop हो जाता है, and due to that, when the compound is formed, regularly a tension is there near the fluorine atom and carbon atom, a stretch is there, as well as charge is developed over the carbon. When the polarity comes, many physical and chemical properties of the compound is changed. The first change which is observed, when the charge is developed, what will be happen? This negative charge start to attract positive part. Then again, this positive part will be start to attract negative part like fluorine. So what will be happen? Due to that, molecules are associated. And when the molecule associated, first change that is seen into the compound is physical state. If it is expected to gas, it will be liquid. If it is expected to liquid, it will be into the solid state. So first change that is seen into the polar compound, that will be state of the material, can be into the liquid form or can be into the solid form. The second important property that is changed, that is solubility into the water. Normally covalent compounds are insoluble in water. If they are pure covalent compound, that time they will not dissolve in water, like kerosene, your cloth, wood, they cannot be dissolved into the water. But where polarity is developed, then what will be happen? These organic compounds are soluble in water. So another property they will get, that is solubility in water. Why they dissolve in water? Because water itself polar in nature. And there is rule for the solution. Like dissolve to like. Means water is also polar in nature, and haloalkanes or alkyl halides are also polar in nature. They can be soluble. But solubility decreases when the atom that is attached with the carbon. Fluorine compound will be, fluorine atom will attach, solubility is more. Chlorine have little bit less solubility, bromine and iodine. When iodine compound will be formed, they are least soluble in water. Another property that is get by the haloalkanes, that is melting and boiling point. You are seeing here, these compounds are supported by three kind of bonds. One is covalency, polarity is developed, and opposite charge is there, and due to this opposite charge, they will attract second bond. The third bond, that will be attraction of one molecule to the another, hydrogen bond. So they are supported by three kind of bonds, and due to that, they will carry high melting and boiling point in compared to those compounds who have similar molecular masses, but they are non-polar in behavior. When the compound is polar, their behavior of reaction, their chemical reaction and their type is also changed. I already told you, covalent compound or particularly organic completely depend on the mechanism. Ionic compound have reaction fast and easy, whereas organic compound have reaction slow and they can be takes place by some particular methods that we will discuss in the next video, that what is the pattern of the reaction of the compound. Thank you. Have a good day.